A PC is used for office work at home, research, communication, and all those things. Suppose average number of hours that PC is used for entertainment is 2 hours per day. Assume the times for entertainment are normally distributed. Standard deviation for the times is half an hour. And then find the probability that a household PC is used for entertainment between 1.8 and 2.75 hours per day. First, capture what is given. X follows normal distribution with mean 2 hours, standard deviation 0.5 hours. And A is asking what is the probability that, so what is the chance that the value of X is between these two numbers? And if you make a picture, (1.8) it's to the left and 2.75 is to the right. So what is this area? So what we'll do here is you find area to the left of 2.75 first, all the way, like it will include this also, and then you subtract from that area to the left of 1.8, so that we are left with area in the middle. So to create a picture, let me copy this. I'll call this picture 2. So mean is 2, standard deviation 0.5, and now we have two values. So let's put lower value first. Upper value is 2.75. So these three lines remain same. And now we want to shade from x1 to x2. So we are interested in this shaded part. So always bigger number is first and then subtract so that you get area in the middle. So that is part A. So it says 0.5886. So find the maximum number of hours per day that bottom quartile means 25th percentile, so first quarter, of households use PC for entertainment. Now we are looking at the third one. Mean is still 2, sigma is still 0.5. You run that, you get 1.66. So this area that we were interested in was 0.5886. This area 0.5886. In B, we were interested in 25th percentile. So we used qnorm, and that gave us 1.66. For completeness, if you make this picture, so 25% obviously to the left of 2. So this area was given as 0.25, and we wanted to figure out how much is this. So that was our question mark that we calculated and got 1.66. So this is 1.66. If you make a picture and in your calculation, if you make a mistake, for example, suppose you entered something and you get like 3.9. When you look at the picture, that's not possible because average is 2. So 3.9 cannot be less than this. Try it 6.1. Fill in the blanks. Jerome averages 16 points a game with standard deviation of 4 points. X follows normal distribution with 16 and 4. Suppose he scores 10 points in a game. Z score when X equals 10 is negative 1.5. For 10, if you calculate Z, like X minus mu divided by sigma, so that calculation is already done for you. So it is saying it is negative 1.5. So this score tells you that X equals 10 is dash standard deviations to the left or right of mean, what should we fill here? Yeah?
Negative 1.5 or 1.5.
To the
Left.
left because it is negative of the mean dash.
16.
So mean is 16. So very straightforward kind of question. Golf scores for a school team were normally distributed with mean 68, standard deviation 3. Find probability that a randomly selected golfer scored less than 65. So probability of X less than 65. So first of all, X follows normal distribution with mean 68 and standard deviation 3. So the question is, what is probability of X less than 65? So 65 is to the left of 68 because it is less, and then we are interested in this area. pnorm. To calculate this, what should I put as a first number? 65. So we always start with that number. So 65. Next. So 68 is the mean. So 68. Next number? 3. Standard deviation. So because it is left, we don't have to tell. It is left till because that's a default. So if you plug in this number or this function, you should get 0.159. 0.159. A bottle of water contains 12.05 fluid ounces with standard deviation of 1. Define the random variable X in words.
Wouldn't it be the amount of fluid ounces that were?
Yeah, very simple, yeah. A normal distribution has a mean of 61, standard deviation of 15. What is the median?
Oh, would be 61. Just right around 61.
61 is the mean. What is the median? You are right. If you go back to chapter 2, median is the middlemost value. If you look at normal distribution, where is the middlemost value? Exactly in the middle. And what is in the middle? Your mean. So mean, median, mode, all three are exactly same for normal distribution. Your picture looks like this for a normal distribution. So against the maximum value is your mean or median or mode. Mode is maximum value, median is middlemost value, mean is the average. So all are exactly same if your distribution is symmetric. X follows normal distribution, 1 and 2. How much is the sigma? So sigma captures what? Standard deviation or mean?
Standard deviation.
Yes, 100% right. So how much is sigma? 2. So very simple question. So this is mu or mean, sigma is 2. In the beginning itself, I wrote X follows normal distribution with mean and standard deviation. Like this is your mean and this is your standard deviation. So second one is standard deviation. Estimating binomial with normal. So sometimes some distributions are related to each other. Like I started with the relation where we saw Poisson and exponential are related in some way. Similarly, binomial and normal also have some relation. So the situation has to be something that satisfies this. When n times p and, so both of them have to be fulfilled. N times 1 minus p are greater than 5. Only in those situations. So if you look at one of the situations like this with try it 6.7. Let's assume that only 10% of the wooden furniture made by a carpenter is made to exact dimensions. During the last 3 years, the carpenter has made 100 pieces of such furniture. 16 were found to be made to the exact dimensions. Situation given is a very straightforward binomial because you are given a probability that 10%. So that's P. So binomial, if you recall, we need N and P. How much is N? P I just mentioned it is 10%. How much is N sample size? So first let me write down. So we are given N is 100, P equals 0.1, so that is 10%. And we are interested in finding whether probability of X is more than 16. Now this we can find out from like binomial distribution also, but I just want to illustrate how you can find it using normal distribution. So first we check how much is N times P. So 100 times 0.1 is 10, more than 5. And then N times 1 minus P. So again 100 times 0.9, so that is 90. So both are more than 5, that means we can use normal distribution. But before that, you know, normal distribution needs mean and standard deviation. So for binomial, mean is N times P, we got that as a 10. And standard deviation for binomial distribution, if you go back and check it, the formula is N times P times 1 minus P. This is 10, and 1 minus P is 0.9, so 10 times 0.9. So 10 times 0.9 is 9, square root of 9. Square root of 9 is 3. So standard deviation is 3. We can capture this as a normal distribution situation. So we are starting with the situation where data is given in the form of binomial, and then we are converting it into this mean and this standard deviation using the formula for binomial. We can make this picture, what is the chance that X is more than 16? So 16 is to the right of 10. So if I put it here, then what is this area? On an average, 28% of 18 to 34-year-olds check social media before getting out of bed in the morning. Suppose this percentage follows normal distribution with a standard deviation of 5%. Find probability that percent of 18 to 34-year-olds who check social media before getting out of bed is at least 30%. This is not a situation where we are converting binomial to normal. This is purely normal distribution situation. First of all, what is given? It says X follows normal distribution with mean 28%. So I'm only going to write 28 and 5% as a standard deviation. So we always write mean first and then standard deviation. So once you have that, part A is asking basically what is the probability that X is more than 30? So 30 is somewhere here, and more means this area. Find the probability that 18 to 34-year-olds who check. So sometimes when you read the question, there are so many numbers that can confuse people. But that 18 to 34 we are not using anywhere. That's the background. That's your random variable X. How often 18 to 34-year-olds check their social media? That's our random variable. We are not using those numbers anywhere in the calculation. What we are using is check social media before getting out of bed at least 30%. So that's the number we plotted. Find 95th percentile. So you have X28, standard deviation was 5, right? And 95% of the area to the left means I have to use something to the right of 28. Otherwise, I cannot get 95%. So this area is 0.95. So that is given, and we are interested in figuring out how much is this value. So that's where we bring our Q. So qnorm 0.95, 28 and 5. That is about 36.22. So this value here is 36.22%. So that should complete chapter 6